So for this final problem, it's a little bit longer. Basically, how to find is it says here, find the x component of the velocity of the package just as the force to stop each of the following cases. So here's more or less the work that I did. We know the mass is 25 kilograms, and we first going to find the work. So the work is the force times displacement of x, which we can see here is 4, based on 6 minus 2 is displacement. 200 times 4 equals 800, and since it's a triangle, we divide it by 2, which is 400 joules. Now that we have that information, we have to find the change in the kinetic energy. So kinetic energy would be kinetic energy final equals the 400 plus kinetic energy initial. And kinetic energy is basically 1/2 of the mass times the velocity squared. And it gives us the velocity, so we go ahead and plug in that numbers, and we have the kinetic energy final equals 850 joules. So now plugging in that kinetic energy final, which is again 1/2 of the mass times the velocity final squared, equals 850. When we isolate that BF squared to one side, we're left with square root of 68, which gives us 8.25 meters per second. And that is basically how we find what the kinetic energy is and what the velocity is, the force that needs to be applied in this circumstance.